Okay, I'm going to begin my next session. In the previous session, we have discussed the theorem of inverse probability, and also I have shown that the how to prove the theorem of inverse probability by the help of the definition of conditional probability. From the note which I shared with you, from this particular note, I have selected one problem which was given earlier as an exercise in the problem sheet. So let us try to solve this particular problem, which is written which is written as practice problem in the problem sheet. So I'm going to do a board work on this particular problem. So first of all, before that, let us read the problem. What is the problem is about? The problem is saying that you also note down this particular problem, the values at least. An explosion at a construction site could have occurred as the result of static electricity, malfunctioning of equipment, carelessness, or sabotage. Okay. Interviews with construction engineers analyzing the risks involved led to the estimates that such an explosion would occur with probability 0.25 as a result of static electricity, 0.20 as a result of malfunctioning of equipment, 0.40 as a result of carelessness, 0.75 as a result of sabotage. It is also felt that the prior probabilities of the four causes of explosion are 0.20, 0.40, 0.25, 0.15. Based on all this information, what is the most likely cause of the explosion, the least likely cause of the explosion? So first of all, let us try to understand. What this problem is saying. Okay. What is not explained in the book? Listen to me very carefully. In the book, you may get several problems. Okay, you may get several situations. You are well enough and you are well capable of solving probability problems. But what is not mentioned in the book at all, that I'm going to tell you. The main fundamental question which arises in the student's mind is that from where do they get these values? What are these values? Where do they come from? So for example, 0.25 is a result of static electricity. Okay, such explosion occurs, 25% chance of occurrence of such explosion due to result of static electricity. What do we mean by that? We mean by that 100 times, if the observation is taken 100 times, 25 times it has been seen that these explosions have been occurred due to the static electricity. 40 times it has been seen that this type of explosion occurred for carelessness. 75 times it has been seen that such explosions occur due to sabotage. 20 times it has been seen that such explosion occurred due to malfunction of equipment. Where do this value come from? They come from a very long, hectic previous data, previous record of the company, of not only this company, of various companies all over the world. Either they have got this from the practical scenario, or just they are assuming by looking into one or two cases, they are saying that yeah, maybe 25% is, just like we do in case of coronavirus, that we have seen that UK strain is present in Bengal. Okay, now if someone asks you what is the percentage of, if someone asks the physicians what is the percentage of this of the patients present in Bengal who have this UK strain, and suppose this physician is attached to AMRI Dhakuria, then he has seen 10 patients with such case. Then he will say that okay, maybe right now at this moment maybe 27% of the population of West Bengal is affected with UK strain. He is just doing it from mind. No statistics is available. No statistics is using. Or he may have got some sort of relevant data from MRI Mukundapur, then from Disan, from RM Tagore, and many other hospitals, and he's saying that this is the record. Okay, so from assumption or from like earlier practical experiences, they got this type of values. What are these values which is written below? Prior probabilities of 4 causes or causes of explosion. How many times there is prior probabilities of this type of explosion? How many times, what is the probability that there will be a static electricity? They are not, these prior probabilities are not talking about the explosion due to the causes. It is talking about the cause. In fact, what is the chance that there will be a static electricity? What is the chance that there will be malfunctioning of equipment? What is the chance that there is a carelessness? What is the chance there is sabotage? Because if there is a malfunctioning of equipment, not every time due to malfunctioning explosion occur. Sometimes it occurs. Not every time due to sabotage malfunction occurs. Sometimes it is occurring. So here in this part, they are interested in finding the probability of these causes only. They are not interested in their effects. Based upon this information, based upon this probability, and the explosion has occurred, we are actually interested in finding what is the most likely cause of the explosion. Okay, so let us try to find it out. So I'm stopping the share. I'm going to the board work. I think discussion of one such problem will be sufficient to understand the relevance of Bayes theorem. Now, solution. First, we define the events, because defining the events is very important. If you can correctly identify the events and define it, then you will be able to solve the problem. First, we define the events which are given in the question. Okay, let E1 denote the event that there is static electricity. E2 denote the event that there is, what was that? Malfunctioning of equipment. Malfunctioning. E3 denote the event that there is carelessness and E4 denote the event that there is sabotage. And the probabilities of these events are given. The probability of E1 is given to be 0.20. Probability of E2 is given to be 0.40. Probability of E3 is given to be 0.25. If I do any mistake, you can write in the chat box to notify me. Okay, so 0.15. All these probabilities are given. One extra probability I have to define. Okay, what is one extra event I have to define, which is not specifically mentioned in the question. Now, this part is very important. So I'm putting a star over here. Let capital A denote the event that there will be explosion, or there is explosion, or explosion has occurred. Let A denote this event. This part is not given in the question directly. You have to identify it. This identification is very important. Now, again, you look into your question and try to find out what other probabilities are. Now they are talking about the effects. So in the question, we are given probability of A given E1. What was written? It was written that there is 25% chance that this explosion occur as a result of static electricity. So explosion has occurred given that there is static electricity. Probability of explosion given that static electricity. Okay, this is the probability 0.25. Probability of A given E2. Let me write all the things first of all. So it is probability of explosion given that there is malfunctioning. Probability of A given E3. It is the probability that there is explosion given that there is carelessness. And probability of A given E4. This is the probability that there is explosion given that there is sabotage. Okay, all these probabilities are given. So let me put the values: 0.20, 0.40, 0.75. 0.20, 0.40, 0.75. All these things are given. Now, what am I supposed to find? I'm supposed to find what is the most likely cause of the explosion. Now, to find, I'm writing over here in this portion, to find the most and least likely cause of the explosion, actually we need to find the following probabilities. We need to find probability of that explosion has already occurred. What is the chance that it is due to? The explosion has occurred. What is the chance? No, there is static. Here I am. Explosion is there. Static electricity was present. Explosion will occur. I'm now going to find out the explosion has occurred. What is the chance that it is due to static electricity? So I'm interested in finding this probability. Explosion has occurred. I'm trying to find what is the chance that it is due to malfunctioning. Explosion has occurred. What is the chance that it is due to carelessness? Explosion has occurred. What is the chance that it is due to sabotage? Now, if I can find all these things, then maximum of this value will be the most likely cause. Minimum of these values will be the least likely cause. I hope you have understood. Okay. To find, now try to recall the statement of the Bayes theorem. To find probability of, I'm writing it over here, probability of E1 given A, this is equal to probability of A given E1 into probability of E1 by probability of A. So here I am going to find the probability. First of all, with respect to this problem, I am going to find what is the probability that there is explosion or there will be explosion. What is the probability that there will be explosion? Okay. What is the probability that there will be explosion? Now, okay. Now, the probability that there will be an explosion is denoted by probability of A. Now, this event A, that there is the explosion, can happen in 4 mutually exclusive ways. How? Static electricity is there and there is explosion, or malfunctioning is there and there is explosion, or carelessness is there and there is explosion, or sabotage is there and there is explosion. So this explosion can happen in this way. So probability of A would be equal to probability of A intersection E1 plus probability of A intersection E2 plus probability of A intersection E3 plus probability of A intersection E4. Or you can write it as summation I goes from 1 to 4 probability of A intersection EI. Okay, and this can be written as probability of E1 into probability of E1 A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3 plus probability of E4 into probability of A given E4. Okay, now you put all the probabilities. What are the values? E1 and A given E1. So 0.20 into 0.25. Okay, 0.20 into 0.25 plus E2 and A given E2, 0.40 and 0.20, 0.40 into point, how much? 20 plus point E3 and A given E3, 0.25 and 0.40 plus 0.15 and 0.75. So a value will come. Can anyone help me to, can anyone find this value and tell, write in the chat box? I do not have any calculator with me right now. So please help me to find this value if you are properly attending the class. Can anybody help me? While doing the calculation with the help, someone has written, let me see. Yeah, Aniket and Obhidov has got the same, yeah, 0.3425. 0.3425. Now, okay. Now we are interested in finding probability of E1 given A. Now, which is equal to, which is by definition is probability of A intersection E1 by probability of A. Probability of E2 given A, that would be equal to probability of A given A intersection E2 by probability of A. Probability of E3 given A is equal to probability of A intersection E3 by probability of A, and probability of E4 given A, that would be equal to probability of A intersection E4 by probability of A. Okay, so now we are going to write probability of this as probability of A given E1 into probability of E1 by probability of A. This can be written as probability of A given E2 into probability of E2 by probability of A. This can be written as probability of A given E3 into probability of E3 by probability of A. And this can be written as probability of A given E4 into probability of E4 by probability of A. Okay, now you have all the values. Again, you help me to find the probabilities. One by one, you substitute the values and try to find the probabilities. So I'm waiting for your reply. Probability of someone has written, Priyashu Gui has written probability of E1 given A is 0.146. Okay, 0.146. Then, okay. Okay, 0.233 or 0.234, same thing. Okay. Shomili has written, which one we have written? Shomili, 0.291. Now I'm just missing the point. First one is 0.146. E4 is okay, 0.328. E4 is 0.328. Okay. 0.291 is 3. Acha, okay. Second one is 0.234. And first one is 0.146. Which is the largest value? The largest value is 0.328. So this is the largest value according to your calculation, and this is the smallest value. So the least likely cause, I'm writing over here, the least likely cause according to your calculation, the least likely cause for this expression is static electricity, and the most likely cause for this expression is sabotage. Okay, according to your calculation, this is the least likely cause and this is the most likely cause. What was the answer? Let us stop the share and let us go back to the PDF file. Yeah, so you have done it correctly. The most likely cause is 0.328 is sabotage, and the least likely cause is static electricity. So actually, this problem is something is you cannot you don't say that this problem is a engineering problem. It's a problem where you are the investigative officer. You have gone. You are collecting things. You are engineers, so you know since you are engineers, so you know that in this type of situations, what can be the cause of the explosions, and you are marking. You are investigative officer. If someone sends me, I do not know anything about companies and these things. So if someone, I know how to do the probabilities only. Okay, I know about Bayes theorem, I know about events, I know about everything, but I don't know that how to identify the events. Listen to me very carefully. I do not know how to identify the events. What can be the events here in case of the explosion? Since you are engineers, you are going over there as an investigative officer, and you have faced such a situation, such a scenario before, so you know that these can be the causes of such explosion. Now you are trying to find out the data from various places, from the companies, from other companies where such similar explosions have occurred, and therefore an investigation takes this longer time. So you are collecting all the information together and you are doing the calculation. You are doing the calculation, and then you are saying that most likely cause that this explosion has occurred in your company is this sabotage. And then your next job is to try to find out who sabotaged it, and you are to nab the criminal. Okay, so that is how the society, the real scenario is running. This is the way by which, with the help of this tool of probability, we can do various other things. Okay. Anyways, I'm happy to see that most of you are doing things properly and attending the class. Okay, so you are attentive enough. Now, this question number 1. So, for example, I'm reading out. Suppose that when answering a question on a multiple choice test, the student either knows the answer or guesses at it. If he guesses at the answer, then he will be correct with probability 1/4. If the probability that a student knows the answer is 0.6, what is the conditional probability that the student knew the answer, given that he answered it correctly? So in this particular problem, we have applied the Bayes theorem. Okay, so you see, I'm not explaining the problem because you have already known that what to do. The most important part is that by reading out these statements, you have to identify what events you should consider. What events you should consider? What is your sample space? Now, in the previous case, which you have done, malfunctioning, sabotage, explosion, static electricity, these were mutually disjoint. Only these things, combination of these, gives you the total sample space. Every possible causes have been taken into consideration. No other causes is left. It is also a part of investigation. Okay. Now, once you design this exhaustive number of mutually disjoint event, now Srimanti wants to say something. Tell me.
Sir, I had a doubt in that sum, this explosion sum.
Okay.
Sir, as you said, these are mutually exclusive events, and these are the only possible options, these 4 options. So, sir, is there a possibility that one worker gives 2 answers? Because here the individual probabilities do not add up to 1. So that means there must be an intersection somewhere.
Yeah,
So
yeah, okay. Is it
the case?
Now, these probabilities, if you add the probabilities, I mean, probability of V1, probability of V2, probability of V3, probability of V4.
So the initial ones where sabotage was 0.7. So I've written it.
Now
0.75.
you are talking about probability of E1, E2, E3, E4.
Yes, sir. So which was basically 0.25, 0.20, 0.40, and 0.75.
No.
So, sir, those two.
Okay. Then in that case, if it is not 1, then I can say, if you are seeing that this is not, the total probability is not 1, that means in this case, I cannot say they are exhaustive, but they are mutually disjoint. Some other cases, some other causes may be there, may be present. But if I take into consideration these causes only, if I take into consideration these causes only, I do not know anything about, they do not know anything about any other causes. On the basis of the causes present, they are giving their judgment. Okay, so it is a matter of what type of, because explosions, in this type of scenario, remember, being exhaustive is a very, I mean, what can I say? It's a very difficult to say that it is, when I am actually giving you the statement of the Bayes theorem, I'm saying that this has to be exhaustive, but getting exhaustive events from out of the practical scenario is a very difficult task. Many other causes which are left, if it is not summing up to 1, then many other causes are there, causes are there which has not been taken into consideration. Now, on the basis of the causes which are left at hand, they are giving the judgment only. Okay, in that case, you are right. I cannot say that they are exhaustive, but they are
here. So here, looking at the given problem, what it seems as if one person has given two answers, that this can be the case or that can be the case.
Yes.
So if we have something like this, then this kind of a scenario can arise.
Yeah,
so
definitely. Your point is that according to the given data available, you have got certain probabilities. But if some other investigative officer comes into the picture, he gets a different data, he may get a different probability. The probability value is not unique, and ever. Chance is not unique ever. It is not deterministic. So you can get different chances. Okay. So just like I told you in the last class, now probabilities are not calculated. We associate the probabilities. So if to someone probability of getting head is 0.5, to me probability of getting head can be 1 also. The probability of getting head is point, for some other people it can be 1/3 also, because I do not know about unbiased scenario. But unbiased scenario is not well defined. Okay, so probability.
So that means the people.
Yeah. Who is?
So that means the people would be changing their responses only in that, because if everybody keeps their responses the same, then we would have landed up with the same thing.
Everybody changes their responses. That is the beauty of probability. Everybody. Now, when a particular newspaper is saying that this many people are affected by COVID-19 disease, this month of May of 2021, another newspaper is giving you another data. Another newspaper give you another data. So if you look at this data in different newspaper, you will see that their percentage is not similar. They are not fixed. It cannot be fixed ever. They are going to get, each time they are going to get different. Even if someone says that till date, the persons recovered after getting Covaxin till today is this much, 25%. In another newspaper, you will get for same date, same vaccination, you may get different probabilities. The probabilities values calculated by two different people can never be same. It is not fixed. It is not deterministic. It can change every time. Depends upon what we are left, what we have in our hand. On the basis of that, we are calculating. Now, these data is 0.25, 0.20, 0.15. These data are not actually, these data are not actually, these data are hypothetical data. If I change the data, then different things may come, and the relevance of these data has not been tested.
So like for the second set of data, which is 0.2, 0.4, 0.25, and 0.15. So here when we add up, we get 1. So that's that matches with our.
You are getting 0.2. That's why I was asking.
Yes, sir.
0.20, 0.40, 0.25, 0.15.
So this is coming to be 1. Yes, sir.
That
Sir,
means,
my problem lies with the previous set of data where the people are giving their responses. So if I consider that everybody has responded and everybody has given exactly one response, then this should add up to 1. In which case I can say that they're mutually.
which problem we are talking about?
So that one, the one which you were showing, the last problem that you discussed.
This one.
The electricity problem.
Oh, achha,
No, sir. So
okay.
the electricity, sir, what I meant was, yes, like here, the second line says that the interviews with construction engineers, and over there they get this data, which is 0.25, 0.2, 0.4, and 0.75. So, sir, considering a scenario where everybody has responded and everybody has given exactly one response, so we should have got a different kind of data where the values would have added to 1.
Yes. No. Those things you are talking about, those are conditional probabilities. Explosion with respect to the in the statement of the Bayes theorem. That's why I was asking previously when you raised the question. I was asking which total you are talking about. They said that E1, E2, E3, En, these are exhaustive. They never said that A given E1, A intersection E1, A given E1, A given E2, A given E3, they are exhaustive. It is not. They cannot be exhaustive. Their total is never 1, cannot be 1. According to the statement, the events, the causes, these are the events, E1, E2, E3, E4. These causes probability is supposed to be 1. If it is 1, then I can say that these are the exhaustive causes. And you are talking about the total of this A given E1, A given E2, that cannot be 1. That cannot be 1. You cannot say that this is 1.
Sir, the initial ones, like,
yeah,
sir,
initial.
can you please once,
board
sir,
work.
can you please once scroll? Yes, sir, the board work.
These probabilities must sum to 1.
Sir, yes.
These probabilities must sum to 1. But their sum cannot be. You cannot say that these sums are 1. We do not know. We are not interested about what are the sums of this total probability. These probabilities. They are talking that E1, E2, E3, E4. Their probability should be equal to 1. Then only you can say that the events are mutually. These events are exhaustive events. That means what? You have considered all possible causes of the explosion.
Okay.
I never said that the probability is A given E1, A given E2, A given E3, A given E4. Their sum is 1 or not. I'm not interested. I'm not interested.
Okay, because we are taking it with respect to whether there's an explosion or not, and then we are checking for the factors. Okay.
Okay. You understood?
Okay.
You understood?
Yes. Okay. Yeah. Now
with this discussion, my time is already over. So only less than 1 minute is remaining. What I was talking about, that the remaining problems which are there in the note, you just go through it. We just go through it, and I think that you will not be facing any trouble to understand those problems since you have understood this problem. So with this, I'm going to conclude my today's session. No more sessions will be taken today. We are going to meet again tomorrow in the scheduled time. Okay, where we shall discuss something else, and I shall upload the videos. So till then, goodbye.